Good afternoon, students. In this session, I am going to discuss about how you are going to convert this NDFA to DFA. Right? In previous session also, we discussed about conversion of NDFA to DFA. In this session, I am going to discuss the very important question. Here this is the very important question you may get in the external examinations also. Right? Here, before going to start this conversion, just I would recall the steps. Right here, in step 1, just we have to create the state table for the given NDFA. Then we have to create the blank state table under the possible input alphabets for the equivalent DFA. Then mark the starting state of the DFA by Q0. Next, step 4 is find out the combination of states Q0, Q1, Q up to Qn for each possible input alphabet. Each time we generate a new DFA state under the input alphabet column. We have to apply this step 4 again, otherwise go to step 6. In step 6, the stages which contain any of the final states of the NDFA are the final states of the equivalent DFA. These are the 6 steps while we are going to convert this non-deterministic finite automata to deterministic finite automata. Already you know that what do you mean by NDFA and DFA. In NDFA, first we are for a single state, whenever we are going to apply any input on a single state, you are going to get one or multiple output states, whereas in case of DFA, whenever we are going to apply a single input on any state, you are going to get only a single output state. Right? This is the procedure to conversion of NDFA non-deterministic finite automata to deterministic finite automata. Let's start this one. Here, see here, P, Q, R, S. How many states are there in this example? Just we have P, Q, R, S, 4 states are there. Now here, whenever we are going to apply 0 input on P, we are going to get PQ, right? 2 states are there. For a single input, we are getting 2 states. So this is the example of NDFA. This is the example of NDFA. Now you are going to convert, now we have to convert this NDFA to DFA. Now we have to convert this NDFA to DFA. NDFA to DFA, right? Before going to start this one, before going to start the conversion, just we have to recall what is the definition of NDFA. In NDFA, how many tuples are there? Q, sigma, delta, Q0 and F. What is Q? Q is the number of input states. Number of states which are present in the NDFA. How many number of states are there here? P, Q, R, S is there, right? So we have to write P, next Q, next R, next S. P, Q, R, S, right? Here, what is sigma? Sigma is the input state, input symbol. How many number of input symbols are there here? 0 and 1. So input symbols are 0, 1. Input symbols are 0, 1. What is this one? This is the delta. So this is the delta. This comes under the delta. Now what is Q0? Q0 is the initial state. How you are going to recognize which one is the initial state? By here, any state which is indicated by the arrow mark, that state is the initial state. In this given example, which state is indicating by the arrow mark? See here, this is the arrow mark is there. So here Q0 means initial state. In this given example, initial state is P. In the given example, initial state is P, right? Here, which one is the final state? Here, star mark is there. Here, whenever any state is going to indicated by any star mark, that particular state is known as the final state. Here in NDFA, we may have number of final state, or else we can have one final state, right? Here S is there, final state is there. In the given example, we are having only one final state, that is S, right? Here this is the given NDFA. In NDFA, we are having 4 states. P, Q, R, S state is there. Here number of inputs are 0, 1. Then initial state is indicated by the arrow mark. So in this case, initial state is P. Next one is the final state is indicated by double circle or else star mark. Here final state is S. Why? Because final state is indicated by this star. That's the reason S is known as the final state. S is known as the final state, right? Now we are going to convert this NDFA to DFA. Now we are going to convert this NDFA to DFA. While we are going to converting this NDFA to DFA, we have to start with the initial state. We have to start with the initial state. See here, create a state table for the given NDFA. Already state table is there. This is the state table, right? What is the second step? Second step is create a blank state table under possible input alphabets for the given equivalent DFA. Then in step 3, mark the start state of the DFA by Q naught. Here we are going to start with the Q naught. Here we are going here state table is there. What is the input symbol? Input symbol is 0. Input symbol is 0 and 1. 0 and 1, right? Here, whenever we are going to convert this NDFA, whenever we are going to convert this NDFA to DFA, we have to start from the initial state. In my example, which one is the initial state? P is the initial state. So, I am going to start with the P. P. Now, P on 0, how many states I am going to get? P comma Q. P on 0 is P comma Q. P on 0 is P comma Q. P on 1, P. Already P is there. Now P on 1 is P is there. P on 1, P. How many states here we are getting? P comma Q and P. In this P comma Q is the new state. Whenever we are going to get any new state, we have to we have to apply the given inputs on the new state, right? Here P comma Q is new state is there. So P comma Q, PQ, right? See here P, already P transition is there. Here already P transition is there. So P is not the new state. So no need to write the transition for the state P. Here only one new state is there, P comma Q. So we have to write the transition for P comma Q. So P comma Q, right? Now we have to apply 0 input on P comma Q state. We have to apply 0 input on P comma Q state. Now P on 0, here two states are there, P comma Q, combination of two states are there, P comma Q. So first we have to apply 0 input on P, then we have to apply 0 input on Q. P on 0, what is P on 0? P on 0 is PQ, P on 0 is PQ. Next, here Q is there, Q on 0, Q on 0 is R, Q on 0 is R, right here R. Q on 0 is R, right? P on 0 is PQ, Q on 0 is R, right? Next, P on 1, P on 1 is P, P on 1 is P, P on 1 is P. Next, Q on 1, Q on 1 R, Q on 1 R. So here whenever we are having multiple states, we have to take one state and we have to apply the input on that particular state, then we have to write those states, then go for the next state and we have to apply the same input symbol on that particular state. Here PQs are there, first we have to apply 0 input on P, then we are getting P comma Q, then Q on 0, then we are getting this R. P on 1 P, Q on 1 R. This is very important question. Next, here P, for the state PQ, we are applying input symbol 0 and 1. We are getting PQR state, one is PQR state, another one is PR state. Here PQR state, for this PQR state, here PQR is the new state or the old state. See here, check here in this column, is there any PQR state is there? No. So PQR is the new state. So we have to write the transition for PQR. We have to write the transition for PQR. Next, PR. Is there any PR state is there here? No, PR state is not there. PR is also new state. So we have to write the state for PR. PR. First. Now PQR, 3 is here. It consists, PQR is consisting of 3 states. First we have to apply 0 input on P. P on 0, PQ. P on 0, PQ. Then next symbol is Q. Q on 0, R. Q on 0, R. Next, R on 0, R on 0 S, R on 0 S, right. Next, P on 1, P on 1 P, P on 1 is P. Next, Q on 1, Q on 1 is R, Q on 1 is R, right. Next, R on 1 pi is there, null symbol is there, so leave it. Here we are applying 0 comma 1 input on PQR, then we are going to get PQRS and PR. First check for the PQRS. PQR is the new state or the old state. See here, PQRS, is there any PQRS is there? No. So PQRS is the new state. So we have to write the, we have to perform the transition for PQRS. So PQRS, right. PR is there, right, PR. Next is PR, PQR, whenever we are going to apply one input on PQR, we are getting PR state. See here, PR is there, yes, PR is here. So already we are having the PR state, so PR is not the new state. Now I am going to write the, I am going to apply 0 comma 1 input on PR state. P on 0, P on 0, what is P on 0? P on 0 is PQ, P on 0 is P comma Q. Next, R on 0, R on 0, that is S. So PQS. Next, P on 1, P on 1 is P. R on 1 pi, right. Here I am going to apply 0 comma 1 input on PR state. Now whenever we are going to apply 0 input on PR, we are getting PQS. Is there any PQS is the new state? First check for this one whether the PQS is the new state or the old state. PQS, check in this column. Is there any PQS is there? No. So PQS is the new state. So PQS, PQS, right. Next is P. Here P is the new state or old state? P is the, already we are having P state, we are having the transition for the P state. So don't write, we are not going to write the transition for the P state. Now next is PQRS. Next, P on 0, P on 0, PQ, P on 0 is PQ. Next, Q on 0, R, Q on 0 is R. S on 0, S, right, S on 0 is S. Now P on 1, P on 1, P. Q on 1, R. R on 1, pi, null symbol. S on 1, S. So PRS, PRS. Now whenever we are going to apply 0 comma input, 0 comma 1 input on PQRS state, we are getting PQRS 1 state and PRS is one more state. PQRS state, check for this PQRS. Is there any PQRS is there here? Yes, PQRS is there. So this is not the new state. Next one is PRS, check for this PRS state here. PRS, is there any PRS is there? No, PRS is the new state. So we have to write for the PRS. So PRS. For this PQS, now we are going to find the transitions for PQS. P on 0, P on 0 is PQ, P on 0 is PQ. Q on 0, Q on 0 is R, Q on 0 is R. S on 0, S, S on 0, S, right, PQRS, right. Next, P on 1, P on 1, P. Q on 1, R. S on 1, S. S on 1 is S. Now here we are applying 0 comma 1 input on PQS state. Here we are getting PQRS and PRS. Check for this one, PQRS. Is there any PQRS is there in this column? Yes, already PQRS is there. So this PQRS is not the new state. Next one is the PRS. Check for this PRS, whether this PRS is present in this column or not. PRS. See here, PRS is there. So this is not the new state, right? Now, in next step, here which one is there? PRS is there. Now we are going to write, now we are going to find out the transaction for PRS state. P on 0, P on 0 is PQ, P on 0 is PQ. R on 0, next state is R on 0 S, R on 0 S. Next is S on 0 S, already S is there, so no need to write this again S, no need to write this state S again. Why? Because already S is there, right? Next, P on 1, P on 1 is P, P on 1 is P, right? Next, R on 1, pi symbol is there, so this is the null state, no need to write that one. Next, S on 1 S, S on 1 S, PS, right? See here. Now we are applying 0 comma 1 input on PRS state, we are getting PQS and PS. Check whether the PQS is the new state or the old state. PQS, see here, PQS, already PQS is there, PQS is the new state. Sorry, PQS is already there, so PQS is not the new state. Next one, check for this PS1. Whether the PS is the new state or the old state. PS, is there any PS is there here? No, PS is not there. So we have to write the transition for this PS state, right? P, yes. Now P on 0, P on 0, PQ, P on 0 is PQ. S on 0, S, S on 0 is S. Now, P on 1, P on 1, P, P on 1 is P, S on 1, S. While we are going to apply 0 comma 1 input on PS state, here we are getting PQS and PS. Check for this one, PQS, whether the PQS is the new state or not. PQS, check in this column, PQS is there, yes, PQS is there. So PQS is not the new state. So we are not going to write the transition for PQS. Now go for the PS. Check in this column whether the PS is the new state or not. Here PS is already there. So PS is not the new state. Here we are not getting any new state, so we have to stop the process. We have to stop the process, right? This is our DFA. This is our the DFA for the given NDFA. This is the equivalent DFA for the given NDFA. Now, after completion of this transition table, we have to select the final state. So we have to select the final state. How we are going to select the final state? Here, in the given NDFA, which one is the final state? S is the final state. Wherever the S state is present in the given transition table, wherever S is present in the DFA's transaction table, so that particular state becomes the final state. Check for this first state P. So S is not there. Here S is not there. Here S is not there. Here also S is not there. Here P, Q, R, S is there. So this state becomes the final state. So this state becomes the final state. So see here, this is the final state, right? Here, why? Because S is there. S is the final state in the given NDFA. Next, PQS, S is there. So this state is the final state. So this state is the final state, right? Next, PRS, here also S is there. Here also S is there. So this is also the final state. So this state is also the final state. PRS is also the final state, right? Next, PS is there. PS is there. So here also S is there. So this state also becomes the final state. This state also becomes the final state. So here in this DFA, we are getting 4 final state. 4 final state. How many number of states are there? 1, 2, 3, 4, 5, 6, 7, 8. So we have to draw this one. for 8 are there, 8 states are there. So first I am going to draw the states first. 8 states I am going to draw here first. Eight states are there. First here I am going to write one state is P here, one state is P, right. Next state is PQ, next state is PQ, next state is PQR. So PQR, next state is PR, next state is PR, next is PQRS. Here this is PQRS, next state is PQS, PQS, next state is PRS, PRS, next state is PS, next state is PS, right. States are completed. Now states are completed. Here initial state, which one is the initial state? This one is the initial state. So P is the initial state. Now find out the final states. Find out the final states here. PQRS is also one final state. So PQR is also one final state. So here we have to double circle with this one. PQRS is one final state. Here also PQS is also one final state. Yes, next is PRS is also one final state. So right, next is PS is also one final state. PS is also one final state. Right. Now P on 0, PQ, P on 0, PQ, P on 0, PQ, P on 1, self loop, P on 1, P, P on 1, P, PQ on 0, PQR, PQR on 0, PQ on 1, PR, PQ on 1, PR, right. PQR on 0, PQRS, PQR on 0, PQRS, PQR on 1, PR, 1 PR, right. PR on 0, PR on 0, PQS, PR on 0, PQS, PR on 1, P, PR on 1, P, sorry, right. PR on 1, P. Now PQRS on 0, PQRS, self loop, PQRS, PQRS on 1, PRS, 1, right. PQS on 0, PQRS, PQS on 1, PRS, next PRS on 0, PQS, PRS on 0, PQS. PRS on 1, PS. PS on 0, PQS, PS on 0, PQS. PS on 1, PS, self loop. So, this is the DFA, this is the DFA for the given NDFA, this is the DFA for the given NDFA. Here this DFA is consisting of 8 state PQRS, PQ, PQR, PR, PQRS, PQS, PRS and PS. Here wherever S is there, that particular state becomes the final state. Here this is very important problem. Here you may get in LAQs. Thank you.